I created a whole brand new presentation to be able to present tonight. So I'm excited about having something new and different to be able to tell the story of some of these amazing things that we're doing at NASA. And one of the things I find especially cool about the work that I do and the satellite mission that I support is that not only does NASA study other planets and the sun and the moon, but we also study our home planet. And of course, we do it often from the vantage point of space. So I thought I would call this talk 2023, the year of open science. And I'll explain why I have chosen that for this talk. So here I am in the hat that I wear as an outreach coordinator. What I often do is I go in public, and also, as I'm doing here, work with people virtually and help to tell the story of how and why we are collecting data from a whole lot of different instruments, a lot of different satellites, and sometimes even flights in airplanes and other ways where we're collecting data in order to better understand and then also ultimately protect our home planet. You already got my introduction, so I'm not going to worry about explaining any of those things there. I will tell you that over here is a QR code. And if you happen to have any of this fancy technology, I'm holding up a cell phone here, just kind of disappears there. If you have any of this fancy technology, you can take that and you can take your camera and shine it on that QR code. And then you will actually have access, I guess that didn't work too well, to this whole presentation. And don't worry, even if you don't shine your phone on that QR code, we will put the link for this presentation in the chat box. And then you can come back and take a look at some of the things. Because I try in my presentations to give you a taste. I heard this saying once, and I just love it. It tastes like more. I hope some of the things I'm presenting to you today will taste like more, and you'll be intrigued. And some of you will think, I'd like to learn a little more about this or a little more about that. So you will have access to this presentation and everything that I'm presenting to you, plus some little extra things, extra for experts, should you so desire. So did my introduction. I'm going to then talk to you a little bit about this year of open science and explain what open science is. Then I'll stop and see if there were any questions. Then I'm going to go on and I'm going to tell you a bit about the satellite mission that I work for. And then I'll stop and again see if there's anything that piqued your interest. And then I'm going to finish up with inviting you to come and play with us, to help us, to contribute to this huge array of open science that we have, and show you a really easy way, again, using this incredible technology that you happen to have, this computer and data collector, and invite you to give it a test run. All right, so let me start off here with this whole idea of open science. And open science is basically the principle and the practice of making research products and processes available to everyone while respecting diverse cultures and maintaining security and privacy and fostering collaborations, reproducibility, and equity. So it really is, it's a big umbrella, and we know it's possible because we here at NASA have had our data open and accessible freely to every and anyone. And I'm going to show you a little bit more about that and how you can dig into all kinds of really, really cool things. And why is this the year of open science? Well, the White House Office for Science and Technology proclaimed that this was going to be the Year of Open Science, not just for NASA, but for a huge variety of different federal agencies. So I've opened one of these links. I'm going to come back here and show you what I did. So when you have this, you can go in and play with it if should you so desire. This over here is called a button. So I just come to this button and I push it. And what I have embedded there is this website. And so this is explaining what I just did about what open science is, and then telling you all of these different federal organizations that are involved in this effort to make it so that all data are accessible. And it really goes a long way in promoting equity, because you can imagine if we have a transparent way of looking at lots of different factors, both on and in the earth and from above the earth, we can sure have a lot of information to help us solve some of these wicked problems. I'm not going to go through each of these, but I'm just going to show you, if you kind of come into this website, you can go down and learn more should you be interested in finding out more about this Year of Open Science. So I was mentioning that NASA data is and has been available to any and everyone. So I've put on here a button called Earth Data, and this is kind of your gateway to coming in here and playing with NASA data. Now, some of this data has been kind of cleaned up a little bit to help you know how to read it, but some of the data, for those of you who might know how to get in there and play with it, might know how to massage it, you can also get the raw data. I'm not, again, going to go through all of this, but I'm just going to show you on this website. It tells you here how to get started. One of the things I would highly suggest that you do, let me see if it's on here, but is that you make yourself an account. It's got to be in here somewhere. Maybe under the Get Started. Let me just see, because I wanted to mention when you make, this is really cool too. You can get in here and it's scaffolded so that if you're new to the data, it'll take you on a different pathway and so on and so forth. But this is what I highly recommend that you do. Go ahead and register, because that will enable you to have access to more data. When you register, I'm going to just see if I can get in here and show you. Let me pretend I was going to register. And I just wanted to show you this because it asks you some questions and they really don't care. Maybe I can bring this bigger. Yeah, they are just basically trying to get metrics on who's using and looking at this data. So other than giving you a password one time, they will not get in touch with you. They're not going to bombard you with emails or sell your email to anyone. And they're going to ask you a little bit about affiliations and study areas. It is fine if your answer is, I'm not studying any of this, I'm just interested. So make sure you register, and you'll just have, and you don't have to, you can get in there and play with it and see if it looks like something you might want more data for. But that is an amazing website. I think you will be enthralled with the various kinds of data and what you can learn for literally anywhere on Earth. And then not only do we have this open data and so many ways of being able to easily access and interact and engage with our NASA data, but we also invite you to the table. And I'll do a deeper dive into this in a couple of minutes. These are some of the different citizen science efforts that we have that any and everyone are invited to become a part of. I'm going to be telling you more about Globe Observer and sharing information about that. But at some point in time, you might take a couple of minutes and go through all of these different projects and see if any of these catch your eye. Many of these, most of these are things you can do from the comfort of your couch. So just something to consider. We definitely need the help of every and anyone who would be willing to come and help us out. and collect this data, which then will be available to you to be able to use. So I'm going to stop for a minute, and Stacy, I'll check and see if there's any questions before I move on.
I do not see any yet, but please, this is a good reminder for folks. If you have any questions, feel free to drop them into the chat box or in the Q&A, and you can also raise your hand to be unmuted.
Marvelous. Well, then let me jump in here, and I'm going to tell you a little bit about the satellite mission that I support. And I'm even going to show you how you can access data from this satellite the same way. Well, it's a different way. There are different processes depending on the data that you want, but I'm going to tell you a little bit about this data because it's the mission that I support. What we're looking at here is, and this, I think I started this from a few days ago when I made this presentation. So this is looking at last week, and we're basically following the precipitation that was measured by the Global Precipitation Measurement Mission. So what we do is, and I'm going to tell you what you're seeing in this data before I tell you how we collect it. But basically, every 30 minutes, anywhere on Earth, we're able to measure precipitation as it falls from the clouds. So if you look at the key down on the bottom, you'll see that we're measuring not only liquid precipitation, and what we're interested here is how much is falling. We're measuring, in this case, we're looking at millimeters per hour. And then we also can measure frozen precipitation. Sometimes I like to show this without even showing the key and have people take a look at this data and tell me what they think they're seeing. Something that I always find mesmerizing is the fact that I learned about global wind patterns as a kid in school, and I'm sure I had to draw maps, and draw arrows on them. But when I look at this data, it makes it so apparent the directions in which the clouds are moving and how fast the clouds are moving. Because, of course, if we're measuring the precipitation as it's falling from the clouds, we're also getting wind direction and wind speed. And note that in the northern and southern hemispheres, those winds are going from west to east. And then we've got that really neat kind of circulation conveyor belt down at the equator where they're moving in the opposite direction. They're moving there from east to west. So you can really follow these. You can see these tropical cyclones. This is the one that's hitting over Indonesia and over in Southeast Asia that they've been very, very concerned about, coming right up there. You can certainly follow the snow patterns, and you can see over here places that rarely are receiving any precipitation at all. And then, of course, based on where you are here in the United States, you can see precipitation that perhaps had been visiting you. Down here, this is telling us our date. So,
Can I interrupt you for a question? Awesome. So we have a question in the audience from Dennis. He's wondering, is the frozen precipitation measured as equivalent liquid millimeters?
Oh, thank you so much for that question. That's exactly right. So when we're talking about our snow and our freezing rain, we're always talking about the liquid equivalent. So if you were to take that and melt it, because that's the only way really to be able to compare apples to apples. So excellent question, and thank you very much for that. Yep. So I'm going to take a sec here and show you what this hunk of metal looks like. It is the size of a fire truck. And it was largely built at Goddard Space Flight Center in Maryland. But something that is super cool about this is it is a collaboration with the Japanese Space Agency called JAXA, and they built our precipitation instrument right here. It's our GPM microwave, our GPM microwave imager. And so that was built and shipped over from Japan. And then down here, we have two radar instruments. One is active and one is passive. So basically, we're just measuring the absorption and reflection at the microwave level of data that is being emitted and absorbed by the clouds. And so with our microwave imager, we're able to see kind of like an X-ray. What kind of particles are in the cloud? Are they little misty bits of rain, or are they those huge raindrops you have that are falling down during a storm? Is it frozen precipitation? How large are the snowflakes? It's incredible what we're able to learn based on algorithms and a lot of ground validation using that microwave data. Then these are some other satellites that are up in orbit from other countries. A few are also, one's a Department of Defense. I can't tell you what it's doing or I'd have to kill you. Another one is a NOAA satellite. Some are from, like I say, several other countries. And they're not measuring precipitation per se, but they have on board a microwave imager, and they're able to measure the data that we need at the megahertz that we need. And then they share it through, we call this our core processor, our core observatory. And that way we're able to, every 30 minutes, everywhere on Earth, measure how much precipitation and what kind of precipitation is falling from the clouds. And then with our radar, it's really cool. We're able to actually get a 3-dimensional analysis. Now that's only where we're flying over. So that's not for everywhere. But sometimes we luck out and we happen to be like flying right over, say, that tropical cyclone, or this heavy, band of snow or rain. And then we get the 3-dimensional information as to how much precipitation is falling and what the rate is. So I wanted to show you another thing here. If you were interested in finding out how much precipitation fell at your specific location, I have an activity I made called From Satellites to Your Backyard. And I guide you through 5 steps that you have to take once you're on that Earth data site. I have you go through something called Giovanni, and then you create this line graph, or you don't create it, it's created for you for anywhere on Earth. And you can look at your seasonal precipitation that has fallen for anywhere on Earth over the past 22 years. Now, the reason it's 22 years is we launched in 2014. We're just coming up on our 10th anniversary. But we're a follow-up mission for a mission that launched in 1997, also a cooperative mission with Japan. And so we have this long 22-year record of data now that went through the process of making sure we had a lot of ground validation so we could tell that it was valid and reliable. This I'm not going to go into a lot of detail other than to show you. You can go to, and come back to where I was. This is that breadcrumbs link if you want to follow the breadcrumbs to find your own data. Here, I wanted to show you who's using this data. It's amazing to see these different examples, case studies of people who have been using our data and found all kinds of amazing ways of using this freely available data to maybe track zebra migration or predict outbreaks of vector-borne and water-related disease, and a huge variety of other things as well. If you happen to have some grandkids who are trying to figure out what they want to do when they grow up, you could take them on there and have them take a look at some of the different STEM careers that are out there that perhaps they didn't really know about. And then before I break for question, I just want to show you one more thing. We're coming up on our 10-year anniversary next year. We're going to have a series of free webinars once a month. And on this website, we'll start to let people know about those. They'll be on things like the water cycle, weather and climate, on topics that we feel like the general public would be interested in. And then we'll share how data from this mission has helped us to increase our knowledge or better respond to some of these wicked problems that we have. And I also feature every month one of our resources that is kind of an exemplary resource that you might want to use to better understand various aspects of our home planet. So let me stop there before I go to our last little section, which is inviting you, and just see if there were any questions.
All right, I don't see any new ones coming in, but this is pretty awesome.
No worries at all. It's and no questions isn't a bad thing, so no worries. All right, the last thing I promised I was going to do is I showed you all those different citizen science efforts that are free and available to any and everyone who would be interested in participating. So many years ago, I believe it was back in, yeah, here it is, 1994, there was this joint agreement between the Department of State, NOAA, NASA, and the National Science Foundation to at this point in time, it was to basically work with teachers and students and scientists and teach students and teachers how to systematically collect data in a very organized way, so that not only could they be a part of collecting this open science data, but they could also share this data with other people all over the world, and then try to figure out things about their home planet, answer questions that they might have, and give them a better feeling for being a steward of their home planet. So that started out in 1994 and is an incredibly robust program. If you click on this little box here called Globe, you can go in and you can learn a lot more about this program. Feel free to share it with anyone. It is freely available to everyone and anyone. If you wanted to look at the data, this open data that I mentioned, you could go right there and it tells you how to go through and take a look at the data. In order to do Globe, we have these different ways of doing it, these protocols. You could learn more about that if you were interested in it. But in 2017, when we realized that people were going around with these wonderful smartphones and also iPads, an app was developed to be able to empower everyone. So it didn't have to be a teacher or a student, and you don't have to have any special training, because the training is all embedded in this app that you download on your phone. So it's basically, the app is called Globe Observer, and it's a free app. It's available on both Android and Apple phones. And this here is a website that, should you want to get in here and play with this app on your phone, I would recommend also taking a look at this website, because if you have questions, and also if you want to get a feel for how is this data helping scientists, and what am I learning by collecting this data? In this case, this is using what we call the cloud tool. So you go outside and you look at the clouds. So you can do this pretty much any time of day except when it's dark. And you take your smartphone and it walks you through the different data that it needs from you. And then you take pictures. And it actually will even take the pictures itself once you're at the point at which it wants your phone off of the horizon. It has like a little ball, and you just kind of move your phone over until it fills that little ball, and snap, it takes the picture. Because in your smartphone, you have a compass, and then also, so that's what it uses to collect this data. So here we have 4 different tools. So you can help us better understand clouds, potential mosquito habitats. So you're looking there for places where there's sitting water, land cover, which is really interesting. You're just taking pictures in 4 directions and up and down on what you see around you. And then finally, tree height. You'll just stand there and look at a tree and measure the tree height. Now, another thing that's kind of cool about coming here to this website, if you come here to trees or any of these and you say taking observations, then you're going to find a very short, I think it's about a 1.5 minute video that tells you what the directions are. Then we've got some kind of frequently asked questions and a little more information. So it makes it so that you don't feel like you're all alone in trying to figure this out. There's nothing you can do to hurt to hurt when you're collecting data. If you mismeasure a tree, or you think a cloud is a cirrus cloud and it's really a stratus cloud, nobody will call your house, no one will email you. You really are building to this open science reservoir by taking these pictures and by sharing your observations. So please, download the app, get out there and play with it. You're not going to hurt anything, and the more you do it, like anything else, the easier it will be. And I also put on here my email address. Feel free to reach out to me if I can be of assistance to any of you. And if you will please be sure, since I can't seem to get into the chat, Stacy, if you would be sure to share the link for this this website so that everybody has access to this after this talk, and you can get in here and you can interact with any of these things that I've talked to you about. And with that, I'm going to stop.